Hello. In this video, we're going to look at creating a decision tree in JMP. Specifically, we're going to see how to customize such a model. We're going to start with how to create one in Python, just quickly giving an overlook of the outcome or the results. But then we're going to dive deeper into the customization capability in JMP. Okay. So the data table that I'm going to look at today is a wine table where I have three cultivars, if you want, or three type of grapes that I have. I have class 1 or type 1, 0, and 2. And the data table shows multiple characterization tests that were done on the grapes or on the wine specifically to help us find out what's the source of the wine. So let's start first with the outcome that we will get from in Python. So I ran the test, and showing here, I'm showing if I were to do a split of the training and the testing data and so on, and finalizing it with just showing the model or the plots. So without going into the details of the code, which are going to be available or attached to this blog, we can see over here that the decision tree was done over some of the characterization methods, with color intensity being the first splitting factor, followed by proline, followed by ash, here by alkalinity of the ash, malic acid, etc. So, overall, this is a fantastic model that can be used, and there's nothing wrong with this model. However, from a practical point of view, if I'm a scientist who needs to use those specific characterization method, I'm going to have some issues here with, the number of tests that I need to do or perform, and whether are those the best characterization tests to perform, or are they the easiest, or are they the cheapest methods or tests to run. So let's see together how I can customize this model in JMP and use my subject matter expertise to decide on the characterization tests that I would recommend performing to, analyzing the wine and finding out which cultivar it's coming from. So let's go to JMP. So again, this is my wine data table. What I'm gonna do is click on this analyze method or analyze menu, predictive modeling, partition. I'm going to take all of these characterization methods as my X factors and my target as my Y response. And over here, the method that I'm gonna use is decision tree. And if this was not already filled up, we can put in 0.3 for the validation portion. And I'm gonna click OK. What I'm gonna get is this decision tree where I can split, prune, and go. So let's talk a little bit about what's going on. If I don't do anything, my three levels or my three classes or whatever you want to call them, if I don't do anything, the probability of using or saying that my cultivar is 0, 1, or 2 is roughly 30% amongst those three levels. A little bit maybe more for the level 1 because I believe there's more data from level 1. And if you don't have this probability menu, just make sure that under the red triangle and the display options that we have this show split probability showing. Okay, so I'm going to click on show split probability. So let's see what happens if I click on go. Let's click on go and let's see what happens. So because I had this validation column added or split, I get this go button. So it's not only Jump Pro feature, it is available in regular license as long as you make sure that you have a validation portion. And what we see here is that the model have created, or Jump has created a decision tree model with I see flavonoid was the first decision criteria, followed by color intensity, followed by proline, alcohol, and total phenol. So overall, I need 1, 2, 3, 4, 5 different characterization tests to decide on whether my wine is coming from 0, 1, or 2 class of the grape or the cultivar. Okay. So this is great. The problem though is twofold. One, this is a high number of characterization tests. So maybe I have a strict budget and I would like to run less tests. Okay, and maybe some of those tests are more expensive than others. So maybe I would have been able to identify which class using another type of characterization method. So let's see if we can do something different, use some other characterization methods, customize essentially this decision tree. So what I'm going to do first is prune. So I'm going to prune all the way back to the beginning, essentially. And I'm going to click on this candidates menu to see all the candidates, all those characterization tests that were essentially candidates to splitting my data. But first, I'm going to order them by their chi-square value. So I'm going to click on sort by column and click on candidate chi-square. And then I'm going to see here that flavonoid was the best characterization splitting criterion over which I'm going to split the data. So that's fine. Let's over here allow it to split. So either I can just click on split, and what's going to happen is going to do that decision of splitting flavonoid over the value of 1.41, or I'm going to prune again. And under this red triangle, I have these options of split best, split here, and split specific. So split best is going to be doing the same thing. Okay. I can prune below, and I can just click on split here, which is going to do the same thing, prune below, or if I click on split specific, I can choose the parameter over which I'm going to perform that split. And I'm going to be able to decide on the value at which it's going to split. So the value, I believe, was 1.41, so I can change the value, okay? But for now, let's keep it at split best because, I believe flavonoid is a good candidate, or it's a good characterization test. And I'm going to open the candidates for the following splits. I'm going to do the same thing with sorting these two. And, essentially look at what are the following characterization methods. So I can see, for example, proline and alcohol are in the top, and their chi-square values is 90 and 80, and they are relatively close. If I just calculate quickly the difference, 90 minus 80, so 10 divided by 90. So it's roughly 11% difference. And as a rule of thumb, they are quite close to each other. So using, alcohol compared to proline might just be, okay as a characterization splitting test. Okay. And the reason why I'm doing this is because from my subject matter expertise, I know that, testing for the alcohol content is much easier than the proline content. Okay, so I'm going to do a split here, or sorry, split specific, and I'm gonna use the alcohol with the optimal value, that's fine. And I can see now that for a flavonoid value of more than 1.41, rather than having a probability of half and half to have the grape coming from the cultivar 0 or 1, I was able to do a better prediction of my cultivar based on the alcohol content as well. So my grape will have a probability of almost 98% to be from the cultivar 1 if the alcohol value was less than 12.93, whereas it's at the 85% probability to be from level 0 if the alcohol was greater than 12.93. And if I look at the candidate, so this is fine. This part, this branch, if you want, this is excellent for me. I can, make that decision on the level 1 pretty easily. Whereas over here, let's continue with sorting. I can see that proline and color intensity are the top candidates. Okay, but so now my decision here is that since I'm most likely going to use the color intensity over here, and I don't want to have to use another characterization test, for instance, I'm just going to split here using the color intensity and keep the color intensity as my parameter of splitting. And that way I will only have color intensity, alcohol, and flavonoid as my three, tests that are required. So over here, I'm going to do split specific of color intensity over the color intensity. Okay. And then over there, I'm gonna keep it at split best, which is gonna be over color intensity. So now this is my my new decision tree, and I'm happy about the R square for the training and the validation. I don't need to be more specific over the separation. I can see here that we can look at the probability. So the probability of being from the class 0 is 95% if color intensity is greater than 3.84, the alcohol content is more than 12.93, and flavonoid is more than 1.41. Whereas for class 1, it's most likely class 1 if it has those two parameters. And for class 2, if it has the color intensity greater than 3.85, but flavonoid value is less than 1.41. This will give me most likely a cultivar, or the wine cultivar will be level 2 or class 2. Okay, so that's pretty much it. This is essentially, in summary, the way you can customize a decision tree in JMP, which is not something you are capable of doing in Python. Again, not to replace Python, but to enhance your Python models and so on by working in tandem using JMP. Maybe then you would want to save or publish the prediction formula, which is this model. You would then generate the Python code, for example, and then you will export this Python code that you created within JMP, so that will be part of your analysis workflow, for example. Okay, but otherwise you don't need to do that. You can stay in JMP and make the decisions using this decision tree. Okay, thank you.